Let's recall some of the basic parent functions we talked about earlier in the year. One of them was f of x equal 2 to the x, which is a basic log function, or sorry, a basic exponential function. And then we had a basic log function, log base 2 of x, and we said these two functions are inverses of each other. So that was the notation for an inverse function. And we looked at their graphs, and we saw that their graphs had the characteristic of inverse function graphs. The log graph looked like this. It has an asymptote on the y-axis and kind of curved up and to the right, going kind of flat but continuing to go up. And the exponential function had an asymptote on the x-axis and behaved like this. And we learned that if the two graphs are a reflection across the line y equals x, they have the characteristics of an inverse graph. This graph went through the point 1, 0. This one went through the point 0, 1, and all of their x coordinates, x and y coordinates, are switched. So this is the log function. This would be the exponential function, that they're inverses of each other. Now, something else that we learned about inverses of each other, or inverse functions, is that if we did f of f inverse of x or f inverse of f of x, it would always equal x. In other words, whatever input value I put into the first function, if I got the output value for the first function and put it into the other function, I would get back to the original input value that I started with. So let's look at how that works with these two functions. Let's do this one first. If I'm going to substitute f inverse of x into f of x, it means I'm going to take this and substitute it for x in this function. So f of f inverse of x would be 2 to the log base 2 of x. And I said that should equal x. Well, let's look at an example of that. Let's say I have, example, 2 to the log base 2 of 8. That should equal 8. Well, what is log base 2 of 8? So I'm going to kind of come over here with my little thinking person. I'm thinking, log base 2 of 8 is equal to 3 because 2 to the third equals 8. So if log base 2 of 8 is 3, then this is 2 to the third, and 2 to the third does equal 8. So this makes sense. So I have this relationship where if these two bases match, then these two numbers also match. Sorry, I had to pause a minute there because of an announcement coming over the speaker. Okay, now let's do the other one. What if we had f inverse of f of x? Well, that means that I would be taking this function right here and substituting it in for x in the log function. So that means I would be taking log base 2 of 2 to the x, and I'm saying that should also equal x. Well, that's a little more obvious because we can say, oh, if we rewrote this, we would say 2 to the x power equals 2 to the x power. That makes perfect sense. So that gives us two relationships. If I have b to the log base b of x, that's just going to equal x. Or if I have log base b of b to the x, that's just going to equal x. So those two are important log relationships that we can look at by understanding that exponents and logs they undo each other. And it also makes sense that they undo each other in this way, showing that they are inverse functions.